For the following three problems, we are going to use the fact that we know that h of x equals the composition of f and g, and the tables giving the functions f, g, and their composition h. So let's take a look at this first one. Number 48, we have to find the value of m. Now here's m, and we notice that the input for h is 2. So that tells us that h of 2 must equal m. So when x, or our input, is 2, the output of h comes out to be m. Well, that tells us that when we use the composition f of g, we're putting in 2, and now we can work from inside out. Now g of 2, we go to our table for g. There's our 2. G of 2 is equal to 1. So f of 1. And now we'll go to our table for f. F of 1 equals 3. And thus we know that h of 2 equals 3, so there is our value for m. Now let's go on to 49. Now we have to find the value of n. So let's first identify where n is and what we know. This is for the function of g, so we know right now that g of 4 equals n. Now how are we going to use that information? Well, remember what happens. G of 4 gets put into f to create h. So let's see what's happening here. So f of g of 4 has to give us some output. Now when we put 4 in, remember that this is not just f of g of 4. When we compose f and g, we get h. So h of 4, which we can see from our table right here, h of 4 equals 5. So that tells us that this needs to come out to be 5. So we need an output of 5 from f right here. Well, to do that, we need to be inputting 2 into f, because we know f of 2 equals 5. That tells us that g of 4 must equal 2. So there is our value for n. Now let's go on to number 50 to find the value of p. Once again, first thing we'll do is we'll identify where p is and what we know. So that's an output for f. So here's what we know right off the bat. F of 3 equals p. Alright, now we need to work backwards here. So remember, f of g of x is our h of x. And if this is going to be 3, remember where that comes from. That comes from g. That means g of whatever our input is has to be 3. So that brings us to right here. Okay, so that means g of 1 needs to be 3. And that tells us our starting point, which is why this is valuable. So now what we're looking at when we put in 1 is we're putting 1 in. That's our input for h. Now when 1 is input to h, what do we get? We get a value of 4. So that tells us that when 1 goes into g, we get 3. The 3 goes into f, we should be getting 4, and that gives us our value for p.